Hello, everyone. So most of our review sessions are going to be through Edpuzzle. So what Edpuzzle does is, first of all, you need to be logged into your Google account because it will record that to me, that you have watched the video. Throughout the video, it's going to kind of just stop. And then on the side, on the right-hand side of your screen, you'll see some questions to answer. Most of the time I'll put a multiple choice question in there because that will give you feedback in terms of if it's right or wrong. Whereas if I put kind of an open-ended question, Edpuzzle doesn't have the ability to give you that feedback. So what's going to happen is I'm going to kind of do a little bit of talking, then it'll stop, ask you a few questions so you can check to see where you're at, and then the video will continue. It is important that you're logged into your correct school Google account. So if you're not, you want to X out and then get back in and watch the video in your Google account so that it sends that information to me. Okay, so I'm going to go ahead and share my screen with you. And we're going to start by talking about fraction operations. But before we even get to fractions, I want to just kind of do a quick refresher on a few things with really basic addition, subtraction, multiplication, division, because we don't want those things to trip us up when we're really trying to work on the fraction piece. So I'm just going to kind of I'm going to use 5 and 7, and I'm going to add, subtract, multiply, divide them all sorts of ways, just to kind of remind ourselves of some basic rules. So if I have -5 subtract 7 versus -5 subtract -7, looking at some addition subtraction things that students sometimes struggle with, -5 subtract 7, another way that I could write this is I could write it as -5 plus -7. Or in other words, I have -5 and then I'm going -7 more. So when I'm subtracting those, I'm really just collecting all of those negatives together, and that's going to land me at -12. One way to visualize this, if you're ever getting kind of tricked up with your addition and subtraction, is a number line where we know if we're adding, we're going to the right, and if we're subtracting, we're going to the left. So if I think about -5 and I have to subtract 7 more, well then I'm going to be on that number line traveling -7, and so it would make sense that my answer is a larger negative there, right? I'm going -5, I'm going -7 further to the left on the number line, landing at -12. Another kind of addition subtraction snafu that students sometimes run into is when we have these double negatives. And so anytime I have a subtract and negative, I can rewrite that as addition. Okay, so minus -7 is the same thing as saying plus 7, that double negative. It's like having, when we multiply, a negative times a negative is going to give us a positive here. And so for this problem, again, if I think about that number line, I'm going to put -5 in a little bit of a different place here. 4, 3, 2, 1, there's 0. If I'm at -5 and I'm minusing -7, or in other words, I'm adding 7, then now I'm going to the right 7. So 1, 2, 3, 4, 5, 6, 7. Okay, I'm adding 7, going to the right 7. It's going to land me at +2. Okay, so as we work through some fraction stuff, we don't want to forget this basic addition subtraction stuff. And then stuff I think that's probably a little bit more solid would be multiplication and division rules with positives and negatives. So just to review, if I had 5 times 7, 5 times 7 is 35. If I had -5 times 7, negative times a positive is going to give me a negative, or vice versa if I had 5 times -7. And if I had two negatives, -5 times -7, negative times a negative is going to give me a positive. these rules are the same when we're having division. So if I had 4 over 2, that's 2. If I had negative 4 over 2, that's negative 2. Or if those signs were flipped, if it was positive 4 over negative 2. Or if I have a negative over a negative, that's going to give me a positive. Okay, so now it's going to ask you a few questions to just kind of solidify those basic integer rules. Now that we have those rules fairly solid, we're going to look at some just kind of review of basic fraction operations. You'll notice that in your summer homework packet, you had some work with fraction operations, and this is a component of the pre-assessment, is how well can we add, subtract, and multiply and divide fractions. So starting with addition and subtraction. Now, addition and subtraction are actually more challenging in my mind than multiplying and dividing fractions, because when we are adding or subtracting fractions, we need to make sure that we have a common denominator. Okay, so before I can even begin the process of figuring out what the sum is, I need to first get those fractions so that they have a common denominator. We're going to go through a few examples, and I'll make sure to include positives and negatives along the way so we continue to practice those skills. So our first example here, we have negative 3/4 plus negative 7/8. So first of all, sometimes students get tricked up when there's like a negative in front of a fraction. So if a fraction is negative, negative 3/4, I could really put the negative either in the numerator or the denominator. But if we go back to these rules with positives and negatives, we know that if it's a negative, okay, the only way that it's going to be a negative is if one of the two numbers is negative. So negative 3/4, what we don't want to do is make 3 negative and 4 negative. Okay, negative 3/4, I would usually rewrite if I had to rewrite this out to get a common denominator. Usually when I rewrite it, I throw the negative right up in the numerator just so I don't get confused, because I don't want to count both of these as negative numbers. If it was negative 3 over negative 4, then it would be a positive. A negative over a negative is going to be a positive. So we just want to be really careful when that negative's living out front to make sure that we're not kind of doubling it up there. So in order to add these together, we need our denominator to be common. And right now we have a 4 and an 8. So in order to get a common denominator here, I'm going to multiply 4 by 2, which would give me 8. And if I'm going to multiply the denominator, then I need to multiply the numerator as well. Okay, and by multiplying them both by 2, I'm not actually changing the value of the fraction. I'm just going to look at a multiple of that fraction. So if I multiply negative 3/4 by 2, that's going to give me negative 6/8. And I think you'll agree with me that negative 6/8 and negative 3/4 are equivalent fractions. And I'm adding to that negative 7/8. Now that I have a common denominator, now I can just go ahead and add the numerators together. So negative 6/8 plus negative 7/8 is going to give me negative 13/8. Okay, but I absolutely need that common denominator before I can do this. Let's look at another example. I have 1/7 minus negative 1/3. So in this example, we have this double negative thing going on. So anytime I have subtract a negative, I just kind of go ahead and rewrite it as addition so that it doesn't trip me up later on. Okay, especially when we get to order of operations or things that have multiple fractions going on. Let's clean that up. Okay, subtract negative 1/3 is adding a third. I can't add these together until I get a common denominator. Now in the first problem, I only had to multiply one fraction to get a common denominator. Okay, because I could make 4 into 8. But on this problem, I can't multiply 3 to make it 7. So instead, I'm going to end up multiplying both fractions by something in order to get a common denominator. So I'm going to multiply the first fraction, top and bottom, by 3, and the second fraction, top and bottom, by 7. And that's going to give me 3 over 21 plus 7 over 21. And now I have that common denominator, so I can add together 3 and 7 to get 10 over 21. Let's look at one more with addition, subtraction, and then I'll let you try a couple on your own. So I have negative 1/4 plus 3/6 subtract 5/3. Okay, so in this problem, I have 3 fractions that I want to add together. And in order to add them together, I need to get all of these denominators common. And so I'm thinking of common multiples of 4, 6, and 3. And I can make 4, 6, and 3, I can make all of these 12 by multiplying the first fraction by 3. The second fraction I'd be multiplying by 2. And the last fraction I'd be multiplying by 4. Okay, so all of those denominators I can multiply and get 12. That's going to give me negative 3/12 plus 6/12 subtract 20/12. Okay, rewriting it so that I have a common denominator. Negative 3 plus 6 gives me 3/12. Subtract 20 more is going to bring me to negative 17/12. If I could have reduced any of those, by the way, I would have. I just can't reduce any of those final answers that I have so far. Okay, so now I'm going to let you try a couple addition, subtraction of fraction problems in this video, and then it'll move on to multiplication and division. Okay, so multiplying and dividing fractions, very different in my mind than how we add and subtract fractions. So when we multiply and divide fractions, first of all, let's just focus on multiplication at first. But anytime we're multiplying fractions, we no longer need a common denominator. So it's actually, in my mind, a little easier to multiply than it is to add and subtract because I don't have to make them common. I do need to be really careful with positives and negatives when I'm multiplying and dividing, and I do want to make sure I'm reducing anything that I can. So when I multiply fractions, I kind of double reduce in my mind. So first, I see if I can reduce anything before I begin. Then I just multiply, and you're just going to multiply straight across. So I'm going to multiply numerators and denominators separately. And then I'm going to see, can I reduce my final product? So when I'm reducing initially, I can reduce any numerator with any denominator. So it doesn't have to be in the same fraction, but anything that's in the numerator can reduce with a denominator term. Now in my first example, I don't see anything that I can reduce here. So I'm just going to go ahead and multiply, and I'm multiplying numerator and I'm multiplying denominator. Now the other thing I need to take into account is the sign. So I have a negative times a positive, I know is going to give me a negative. And then 3 times 1 is 3, and 7 times 2 is 14. And then I look to see if I can reduce again, which on this one I cannot. On our next example, 4/5 times negative 10/11. So on this example, I can reduce one of my numerators with one of my denominators. And so 10/5 can reduce to 2 over 1. And so I reduce first, or really this is negative 10, so I'll write it as negative 2 over 1. Now I'll multiply together the negative 2 with the 4 in the numerator, which gives me negative 8. And the 1 and the 11 in the denominator, which gives me 11. And then I would look to see if I can reduce again. I'm good, so I have negative 8/11. My last example Okay, so here, first of all, with signs, I have a negative times a negative. So negative times a negative is going to give me a positive. I can reduce 4/12. Now note I can't reduce like 3/12. Okay, those are both denominators. But 4 is in the numerator and 12 is in the denominator. Now I could also reduce this way, like 21/12. So I could, I guess, go ahead and reduce 21/12. I'm going to choose to do 4/12 is 1/3. And then I can also reduce 21/3 is 7/1. Okay, so any numerator can reduce with any denominator. And like I said, I could have also gone this way and reduced 21/12 and then multiplied together and reduced again from there. So now multiplying straight across, I get 1 times 7, which is 7, and 1 times 3, which is 3, and there's my answer. So if I had at the beginning negative 4/3 times negative 21/12, if instead of reducing the 4/12 and the 21/3, so I was just trying to reduce as much as I could, if I just reduce this, so 21 and 12, a 3 can go into both of them, that would have given me 7/4 here. And so what I could do is I could then reduce this 4 with that 4, but I think sometimes students miss that. So if I had just reduced the 21/12 and then multiplied, and I would have gotten, so negative times a negative is going to give me a positive 28. 3 times 4 gives me 12. So sometimes you reduce, but you kind of missed another place that you could have reduced before multiplying, and that's okay as long as you reduce in the end. So 28/12 can be reduced by 4, and I still get to the 7/3 there. So now I'm going to let you practice a few multiplication problems before we talk about division. Okay, so dividing fractions, this is one where you really have to practice and get this rule solid in your brain because it's a little bit funky when we try to divide fractions. What I say, so dividing fractions, I use the words keep, change, flip to help me remember how to divide fractions. Keep, change, flip. So let's write down an example and then I'll talk about what keep, change, flip means and how that helps me. So if I have 1/2 divided by negative 1/3. Keep, change, flip. I'm going to keep the first term the same. I'm going to change division to multiplication. And I'm going to flip the last term. So flipping negative 1/3 gives me negative 3/1. So by flip, I mean reciprocal. Okay, that the numerator goes to the denominator and the denominator goes to the numerator. I'm flipping it. Now I have a multiplication problem, and we already know how to multiply fractions. We just reviewed that. So I can't reduce anything here, and I'm just going to go ahead and multiply numerator and multiply denominator, and I get negative 3/2. Let's look at another example of dividing fractions. So I have negative 3/7 divided by negative 6/11. So first of all, negative, negative, it's going to become a positive. I'm going to keep, change, and I'm going to flip this last term, negative 11/6. I kept the first term, changed to multiplication, and I flipped that last term. So negative 6/11 became negative 11/6. Now it's a multiplication problem. So just like when we were multiplying before, I'm looking to see if I can reduce, and I can reduce here 3/6 to 1/2. And now multiplying numerator, negative times a negative. Again, we knew this was going to be a positive, so positive 11. And 7 times 2 gives me 14. So I get positive 11/14. Okay, let's look at one more division problem together and where the format's a little different. So sometimes when we're dividing fractions, it looks like this, where it's like a fraction within a fraction. So this is really 4/3 being divided by 2. Okay, so there's a few things to talk about here. So first of all, well, what happens when we're just dividing and it's an integer and not even a fraction here? What does the flip look like? Okay, I tend to, if I have a compound fraction here, a fraction within a fraction, I like to rewrite it as with the division bar or with a division symbol instead. So now I'm going to keep change and flipping here. Well, 2 is like 2/1. So if I flip 2/1, it just becomes 1/2. So dividing by 2 is the same thing as multiplying by 1/2. And now that we wrote that and we can see that, that makes sense, right? Dividing by 2 is the same as taking a half of something or multiplying by 1/2. Now that we're at multiplication, we're looking to reduce. So I can reduce here. 4/2 becomes 2/1. And now I can just multiply straight across. And that's going to give me 2/3. So that's our last fraction operation that we want to be really solid on before kind of diving into algebra. The video is going to prompt you with a couple division questions, and then once you've completed that, you can look at the practice set for fraction operations.